Hello all my math students. Today I wanted to do some review with you and let you be able to watch it over and over again if you'd like to. Now the first three questions in these slides we covered in our last class. So if you want to see how to do those, watch your class video from Wednesday, February 8th, and you will find them in there. So we've had a long discussion about this one. I showed and we worked together on coming up with this one, and we also talked about this one. So those first three. Now, I'm going to start with number 4 here. Anthony was mapping out a route to ride his bike. The route he picked forms a right triangle as shown in the picture below. You can see the 3 roads that he rode on. If the route takes him 5 miles on Forest Lane, and I suggest the first thing you do is always label your diagram. So since we found out 5 miles on Forest Lane, I'm just going to put a 5 there. Oops, that's a 5, believe it or not. Okay, 5. Let me try again. 5. There we go. That looks more like a 5. And then 13 miles up Cedar Drive. 13 is right there. How far will Anthony ride down Pine Avenue? So this is the distance we don't know right here. Let's label it with our, whether this, where the right triangle, where the hypotenuse is, where the legs are. Now as you can see, it's a very easy one to see that that is where the right angle is. So that means over here is our hypotenuse. So this must be one of our legs, and this must be another one, A and B. Now let's write our equation. So since we don't know what A is, we're going to write A squared. And then the other one, B, is actually the value of 5, so we're going to write 5 squared. And C is 13, so we write 13 squared. Now on this pass, I'm just going to evaluate the squares that I can do. 5 squared is 25. I believe 13 squared to be 169. I'm going to double check myself on my calculator. It is 169. There we go. Now, anytime you have the hypotenuse value, all you're going to do is subtract the square value for the other leg from the hypotenuse, and that'll give us the square of the other side. So 169 minus 25 is 144. Then we're going to take the square root, ink color, that's what I wanted to click on. Then we're going to take the square root of both sides. I wanted to change the color to emphasize that. So A, when we take the square root of something that is squared, we get the thing. So A squared is just A. 144 square root, do that on your calculator real fast. It is 12. So as you can see, the answer to this one is C. Okay, now, which of the following is the best estimate for the length of the ladder if its legs are 13 feet? That's the height of the platform. Again, let me jump in here real quick and label things. This is 13 feet. That's the height of our platform. And 3 feet, the distance from the platform along the ground. So, let's see, 3 feet. This is 3. So it wants to know what is the best estimate. So we're looking for an estimate. We're not necessarily looking for an exact number, but let's figure out the exact number. Now notice, this is our right angle here, so this is our hypotenuse. So we don't know our hypotenuse. That makes it a little easier. We don't have to subtract anything. We're just going to add. So we've got 13 squared plus 9 squared equals x squared. Notice that's an x that they called for our hypotenuse. So 13 squared, let's do that again just to be on the safe side, 169. When you get into those big ones, you just want to be sure. 9 squared is 81, and all of that equals x squared. So 169 plus 81 is 250. So x squared equals 250. So what's the square root of that? We get an odd number. X is 15.8. And I want you to keep in mind I took the square root of both of those. Okay? So it's 15.8. We want to make sure that our ladder reaches to the top. We don't want it to fall down here somewhere and not make it and have to like jump the rest of the way to get on that ladder. So having it between 13 and 13 and a half feet, that's not going to work. Having it between 13 and a half and 14, no, that's not going to work. 178 feet, whoa, that's a bad answer. That's really too big. So we're going to make it about 16 feet. One last question. Electronics, like television screens and computer monitors, are named and sold by their diagonals. Heard that, I'm sure. But Robert has an old computer monitor that he wants to sell, but he can't remember what size it is. But he does know the length is 14. So let's see, we got 14 here. We'll call it down here, all right? 14. And its height to be 6. So he wants to find the length of the diagonal. And that's what we don't know. And here's another thing. The length of the diagonal is our hypotenuse, right? So I'm just going to call it C. Okay. Changing my pink color again, because when I write on white, you're not going to be able to see that. I'm not going to be able to see that. Maybe you can. All right, so we have 14 squared plus 6 squared will equal our C squared. So what is 14 squared? You should be doing that on your calculator while I did it. What is 6 squared? Add them together. Now, some of you might be tempted to say, ooh, 232, I see that answer there. I'm just going to grab it and put C. But if you do, you're going to be fooled, and that is not the final answer. Don't be fooled. We have to take the square root of that C squared. Okay, remember that. We got to do this. Take the square root of both sides. So let's take that square root. And we get a really odd number, kind of. It's not an exact number. Where's my pen? Here it is. We get 15.2. It goes on for a long time. That is our C. So let's look at all our answers. We've got 20, we have 15, and we have 400. Well, 400 is way off. Too big. That's not 400 inches. That's all big. That'd be a nice monitor, though. Whoa, nice TV. 400-inch diagonal. Whew. But 15.2, they don't give it out in exact terms. So, of course, B is the answer. Well, guys, I hope you enjoyed this little review. I hope you're starting to understand how to use the Pythagorean theorem to figure important things out in real life. Thanks for tuning in.